This is an application on how to use ANOVA for independent groups. And you have this actually on Blackboard. So what you have here is we have four types of produces: parsley, cucumbers, tomato, and pepper. And we're looking at the count of, I think it was like a microorganism, to see if the count of microorganism is different depending upon the type of produce we have. So, and what you have this time is you just have the number of parsley. So four parsleys were tested, and the average came out an average of microorganism. I think it's like millions أو شيء, بس إنه it's not that important. What important is the example. So the average came out to be 4.5 for parsley with a standard deviation of 2.2. Cucumber, we only tested two cucumbers, and the average came out to be 2.7 with a standard deviation of 3. We tested two tomatoes. The average came out to be 3.1 with a standard deviation of 1.8. And pepper, we had 6 peppers. The average 2.1 with a standard deviation of 2.5. Obviously, we want to test the null hypothesis is the average of microbial load for parsley equal the average for cucumber equal for tomato equal for pepper. The alternative hypothesis, at least one is different. We assumed the null is true. We set alpha at 5%. And if you want to figure out which test to use, this is where we ask the famous 3 questions. How many groups we have? We have more than 2, yani 4. This is our independent variable. Our outcome variable, our dependent variable, is a measurement variable, and you know that because you're provided with an average. And the groups are independent, obviously. There's nothing that says that the parsleys and the tomatoes and the peppers are matched in any way, shape, or form. So this boils down to using ANOVA, that for independent groups. And the way to do the ANOVA now, I mean, I've done step number 1, step number 2. For step number 3, if you remember, you're supposed to set up your ANOVA table. So the source, between, within, or total, and you need to calculate the sum of squares, the degrees of freedom, the mean sum of squares, the F, etc. So the trick is, how can I calculate the sum of squares between, within, or total? The first thing I notice is I'm provided with a standard deviation for every group. So that tells me I can easily get my sum of squares within. So how do I get the sum of squared within? So I'm just pulling this up to remind you the formula. So the formula, when you're doing the sum of squared within, it's going to be, you're going to calculate the sum of square within group A مثلا, plus the sum of square within group B, plus the sum of square within group C, etc. So you turn this into the standard deviation of group A, you square it, and you multiply it by the degrees of freedom, which is the numbers in group A minus 1. And you also turn this into the standard deviation of group B, you square it, and you multiply it by the degrees of freedom, yani number observed in group B minus 1, and so on and so forth. So let's go back to our example. I'm just going to write a formula. I hope you see that I'm writing the formula right here. I'm going to take the standard deviation, I'm going to square it, and then I'm going to multiply, going to multiply with the number minus 1 so that I get a degrees of freedom. Okay, so this is the sum of square within parsley. Just by copying the formula, I can get the sum of square within cucumber, within tomato, and within pepper, and therefore the sum of square within is simply is summation. So you write sum, open the parentheses, pick these cells up, enter. The sum of square within is 58.01. We're done. Now we need to calculate the sum of square between أو total. هلا for the total كان لازم يكون عندي standard deviation total, which I do not have. لو كان عندي standard deviation total كنت أخذتها standard deviation total, I would have squared it, and I would have multiplied by the total observation minus 1. هن 6 plus 4 10 plus 2 plus 2 is 14 minus 1 كان طلع عندي التوتال, بس ما عندي sum of square, عندي standard deviation total, so I have to do the sum of square between. The sum of square between, again, let me remind you of the formula. The sum of square between is simply you take the average of the first group, or group A, minus the average of the averages. You square and you multiply by the number of observation in A. Then you repeat. You keep doing that لتخلصوا كل group. So in our case, we have the average of A, but the value that we don't have is the averages of the averages. How can I get the average of the averages? Well, the average of the averages is the average of everything. يعني it's the sum of all the x's divided by all the observations. هيدي هون the sum هيدي بنسميها نحن total. So this is the total divided by n. The total itself is nothing but the total in group A plus the total in group B plus the total for every group divided by n. Okay? Type. The total in group A, you can get to it by taking the average of group A times n of group A plus هلا للجروب B, the total of group, the average of group B times the n of group B. Okay, so if you do that for every one of them and you divide by n, that will give you the average of the averages. So let's go back to our example and let's do that. So هلا أنا what I'm going to do is I'm going to calculate the totals. Okay, so the total for group A is just the average of group A times the number of observation in group A. So it's 18. And I do that for all of them. So the average, the total for cucumber is 2.7 times 2. The total for tomato is 3.1 times 2, etc. So by adding up these values, يطلع عندي total of all of the observation, which is 47. And now if I take this 47 and I divide it by قلنا قديش التوتال كانوا 6 plus 4 plus 2 plus 2 is 14. So if I divide by 14 هيطلع عندي the average of the averages. So the average of the averages is 3.357. Okay, very good. So now what I need to do is I need to take every average minus the average of the average square and multiply it by the number of observation. I'm going to do it here. So I come باخد average of group A minus the average of the averages. I square that difference and I multiply by the number of observation. Okay, so هيك بكون عملت this part for group for parsley. بس حتى I need to fix the cell حتى ما تتغير. So I introduce the dollar sign after the letter و after the number. هيك الفورمولا ما بتتأثر. Okay, awesome. All right, so now I'm going to just drag this for the 4 cells. So now I've done the difference between, so هون you can notice if I click on the formula, it's taking the average اللي هو تاع cucumber. No, actually it didn't work. I'm sorry, منيح انتبهت لها. يلا خلينا نصلحها. ما أخذ الدولار sign after. No, it should work. Every time I do that, it's not allowing me. Maybe the dollar sign should be after before. Okay, I hope. All right, now it worked. Okay, so if I highlight the cells, it's 2.5, يعني average of cucumber minus the average of the averages, square, multiply by 2, etc. And that's for every one of them. Now, if you sum these together, هذا بيعطينا sum of square for the between, and therefore the sum of square total is nothing but adding these two together. Very good. هلا degrees of freedom. The degrees of freedom is quite simple. The between is how many groups minus 1. So عندي 4 groups minus 1 بيطلع 3. The within is the total number minus the number of groups. نحن بنعرف إنه we have 14 observation minus 4, so that's 10. And the total degrees of freedom is the 14 minus 1, يعني 13. And we already know that because 3 plus 10 is 13. Now, how do I get the mean sum of square between? You just have to take the sum of square divided by the degrees of freedom. This is the mean sum of square between. Same thing for the within. And now for the f, you take the top one, you divide it by the bottom one, and that is going to be your f. This is the f calculated for degrees of freedom 3 and 10. Okay, now I need to get the f critical. Remember the degrees of freedom 3 and 10. I go to my ANOVA table. 3 و10 بيطلع لي critical 3.71. So the critical is 3.71. You can see إن حد الكالكوليتد بنحط تحت الكالكوليتد بنحط ال p value وتحت الكريتيكال بنحط الألفا. And you can see that our f is less than the critical, يعني the calculated is less than the critical. That means the p-value is larger than alpha, and therefore we're going to fail to reject, and we're going to declare that there's no differences in the average microbial load between these different types of produce, and the difference observed is due to chance only. Okay, I hope you find this example to be helpful.